Chapter 4.4, Trigonometric Functions of Any Angle. We're going to evaluate trig functions of acute angles, find reference angles, and evaluate trig functions of real numbers. So definitions of trig functions of any angle. Let theta be an angle in standard position with x, y, a point on the terminal side of theta, and r equals square root of x squared plus y squared, and that can equal 0. So we know that sine of t is y over r. Cosine of t is x over r. Tangent of t is y over x. Cosecant of t is r over y. And then secant of t is a reciprocal of cosine, and cotangent is a reciprocal of tangent. So just realize that this is x, this is our y, and then here is our radius. And then note that at some points, theta is undefined. So for example, it's undefined at tangent of pi over 2 because that is pi at pi over 2, tangent is y over x, and so y is whatever the value is, and x would be 0, right? So it's undefined there. It's also undefined at secant of pi over 2 as well, because that would be, secant is, well, cosine of pi over 2 is 0, and so therefore it would be undefined, 1 over 0. Okay, evaluating trig functions. Let negative 3, 4 be a point on the terminal side of theta. Find the sine, cosine, and tangent of theta. So we did do this previously, but we did it only in quadrant 1. So now we're looking in a different quadrant. So we know that that point is negative 3, 4. So left 3, up 4. We knew it's negative 3, 4 here. So we find the radius, that is the square root of negative 3 squared plus 4 squared. So that is 9 plus 16, or our radius is 5. So then it just says to find sine, cosine, and tangent. So we know that sine is y over r. So our y value is 4, the radius is 5. Cosine is x over r. So that is negative 3 over 5. Tangent is y over x, so that therefore it is 4 over negative 3. So try to find negative 2, 3. Let negative 2, 3 be a point on the terminal side of theta, and then find the cosine, the sine, cosine, and tangent of theta. All right, if you tried this out, you would see that sine of theta is 3 root 13 over 13. Cosine is negative 2 root 13 over 13, and tangent of theta is 3 over negative 2. So remember, you must rationalize the denominator, okay? Don't leave them improper. So remember the signs of the trigonometric functions. And so this is important when we're evaluating any angle. We have to know the signs of our trig functions. So remember that in quadrant 1, our signs in this quadrant are positive. X is positive, y is positive. In quadrant 2, cosine is negative, sine is positive. In quadrant 3, it is both negative, sine and cosine are negative. And then quadrant 4, we know that our x value is positive and our y value is negative. So looking at that, we know that sine, cosine, and tangent will all have positive signs in quadrant 1. Now in quadrant 2, our sine is positive, but cosine is negative. Tangent, because it's sine over cosine, would therefore be negative. In quadrant 3, our sine is going to be a negative value. Cosine will be also negative. Tangent is negative over negative, which is positive. In quadrant 4, the y value is still negative. In the same quadrant, cosine is now positive, and tangent is going to be negative again. So if you've ever heard of the quick way to remember what signs or what trig values are positive, we think about A, S, T, C. So A means all the trig functions are positive. For quadrant 2, S, sine is the only one that's positive. In this quadrant here, quadrant 3, tangent is the only one that's positive. And in the last one, quadrant 4, cosine is positive. A, S, T, C, all students take calculus. So let's try that in this example here. Evaluate trig functions. Given tangent of theta is negative 5/4 and cosine of theta is greater than 0. So we know that cosine is positive. We need to find sine and secant. So tangent negative 5/4, cosine is positive, so our x's are positive. Therefore, if this is tangent, then our y must be negative. So tangent is y over x. So therefore, it's going to be a negative 5 over a positive 4. So that kind of helps us out there. So what we want to do is we can figure out our radius. So if we're given our x, y, and x, so radius equals the square root of negative 5 squared plus 4 squared. So this is the square root of 25 plus 16, or that is the square root of 41. So the sine of theta is y over r. So this is negative 5 over square root of 41. Then we have to rationalize. So negative 5 root 41 over 41. Secant of theta is the cosine, right? So that's cosine, that's the x, r over x. So our radius is square root of 41, and cosine is 4. And so that's our answer there. So try out this example here. Given sine of theta is 4/5 and tangent of theta is less than 0, find cosine theta and tangent of theta. So if you try this out, you are given sine of theta is y over r, so I set it up and I found x is 3. Now because tangent of theta is less than 0, it's negative, I know that my cosine is negative, right? So sine is positive, but cosine is negative. So therefore I know that my x value is a negative 3. So cosine of theta is x over r, which is negative 3/5. Tangent of theta is y over x, which is 4 over negative 3.